so this is Leetcode 909 snakes and ladders. Okay, so the problem says you are given an n into n integer matrix board where the cells are labeled from 1 to n square in the booster parent style, starting from the bottom left of the board, board n minus 1 0, and alternating direction each row. You start on square 1 of the board. In each move starting from the square current, do the following. Choose a destination square next with a label in the range curve plus 1, minimum of curve plus 1 6 n square. Okay, the choice simulates the result of a standard 6-sided die roll. There are always at most 6 destinations regardless of the size of the board. If next has a snake or ladder, you must move to the destination of that snake or ladder, otherwise you move to next. The game ends when you reach the square n square. Okay, a square on row R and column has a snake or ladder. If board RC not equal to -1, the destination of that the destination of the snake or ladder is board of RC. Squares 1 and n square are not the starting points of any snake or ladder. Note that you only take a snake or ladder at most once per move. If the destination to a snake or ladder is the start of another snake or ladder, you do not follow the subsequent snake or ladder. So let's try to understand the intuition behind this problem. Okay, so intuition. Okay, so we are at starting position 1 and we need to travel to 36. Okay, so this is our end position. So we have 6 rows, and 6 columns. So 6 into 6 is 36. So you need to travel to 36. Okay, okay, and the die has 6 sides. Okay, so which are numbered from 1 to 6. Okay, so from from the first cell, right, from this particular cell, we can either go to 2, we can go to 3, we can go to 4, we can go to 5, we can go to 6, we can go to 7. So this we can travel, okay, with a single move. Okay, so let's say currently our move is 0 and we are at position 1. Okay, okay, next. Okay, so let's say our in the die we got 1. Okay, so in the die we got 1, so where our move will be move 1 and will go to position 2. Okay, but position 2 there is a ladder over here, so position 2 is basically it will be replaced by 15. Okay, so we jump to 15. Okay, next. Okay, let's say in the die we got 2. Okay, so if we got 2, so the move will increase to 2. Okay, and then position will go to 17. Okay, so 17 we have traveled over 17 over here. Okay, and there is a snake over here. Okay, so 17 means, so basically this 17 position will be changed to because of the snake, it will be changed to 13. Okay, okay, now let's say we got die 1. Okay, so then what will be our move 3. Okay, and position will be 13 plus 1, so 14. Okay, and on the 14 position we have a ladder. Okay, so you have a ladder, so we'll directly go to 35. Okay, okay, fine. Okay, now we have position at 35. Okay, so we are position at 35. Okay, and then okay, let's say we got in the die we got 1, again 1. Okay, so move 4 and position is 36. Okay, so 36 was the destination. 36 was the destination. So we have reached our destination. So, and what is the current move? So 4 is the current move, and this is the answer. Okay, okay, so our initial position is at 1. Okay, and we move to 15 with 1 move. Okay, and then we move to 13 with 1 move. Okay, and then we move to 35 with 1 move, and then we move to 36 with 1 move. Okay, so this is our start position, and this is our start position, this is our end position. Okay, and we can see like we are moving step by step, so we are moving from one step to another step, and this we can think of like this is a directed graph. So this is a start position, this is the end position we need to reach. Okay, and we are moving position by one, so we are moving our position by one. So this is like we are sequentially moving our position by one, and this is like a directed graph we can think of. Okay, so if you are moving from step by step, then which algorithm we can think of? So you can think of taking BFS. Okay, so let's try to understand the approach first. Okay, so first we need to maintain a queue. Okay, push into the queue the initial position and move. So our initial position is 1 and move is 0. Second, the third is like we need to maintain a visited array, right? So we need to maintain a visited array or set. So once we have declared a visited array or set, then we need to mark the initial position as visited. So mark the initial position as visited. Done. Okay, now as long as queue is not empty, then we need to dequeue or pop out from the queue, and with the help of the die, we need to traverse the adjacent nodes. Okay, if the adjacent node is not visited, then we need to push or enqueue the adjacent node, and we need to incrementing the move by 1. So we are moving from 1 to 15, right? So you are incrementing our move by 1, right? Initially our move was 0, so when we are at starting position, so in the starting position our move was 0, and then when we our move was 0, and when we move to 15, right, when our move was increased. So that's why over here on the 6th step, if the adjacent node is not visited, then we need to, while pushing into our queuing into the queue, right, we need to increment the move. Okay, 7th is from this adjacent position number, we need to get the row column number. Okay, and if the row column in this row column in the board is not -1, so if the board row column not equal to -1, then we can jump or go back to a new position. So let's say we are at position 2, right? So from position 2 we can get the row number and column number. So row number is 5, column number is 1. Okay, so from column number, so we need to check in the board 5 1 whether it is -1 or not. So in the board we can see like it is 15. So basically from 2 position we can get to 15. Similarly, when we are at position 17, so we are getting a row as, we need to get row as 3, and we are getting 4 as the column. Okay, so again in the board it will be like board, it will be not it will be not equal to -1. So in that case we will be go back to the position 13. Okay, okay. Now how to get the row column number from the position number? Okay, so row would be position -1 divided by n. So n is the board length, which is 6 over here, and column would be position -1 modulo 6. Okay, so so this will get the position row and column. Okay, now over here, right, so when it is aligned in the bootstrap way, so from the first row, from the bottom row, so it is 1 to 6, right, from it is going on the from left to right. On the second row from the bottom, it is from right to left, it is right to left, right, and on the third row over here, it is from left to right again. Okay, so let's say we need to get the column number, row and column number for 12. So row and column number for 12 will be 4 and 0. Okay, okay, so this we need to find out. So currently so from here, right, so row would be 12 minus 1 divided by 6. So if we floor it, so it will be 1. Okay, column would be 11 by modulo 6, which is 5. Okay, so is it matching over here? No, because this row is from the bottom, so we are getting from the bottom, and this column is not, is from the right, so basically it is the fifth column from the right. So basically what we need to do, so if the row is odd, so let's so you can see over here, so if the row is odd, right, so if the row is odd, so let's take this example. This is odd row, this is odd row, this is odd row, this is odd row, this is odd row. So in the case of odd row, so it is starting from right to left. So in case of odd row, it is starting from right to left. So in that case, what we need to do, so if row is odd, then we need to calculate the column from the left. Okay, so in that case, what will be the row? What will be a column? Column would be n minus 1 minus column. Okay, so in current case, which is 6 minus 1 minus 5, so which is 0. Okay, so this we got 0. Okay, and we are getting the row from the bottom. Okay, we are getting the row from the bottom. Okay, so one we got over here, but that is from the bottom, but we need to get from the top. Okay, so in that case, row would be n minus 1 minus row. Okay, so basically in that case, in this case, n minus 1 row is 1, so it is 6 minus 1 minus 2, so it is 4. So you got the 4 as well. Okay, okay, all right. So let's try to code this up. So let's take n, this is the board length. Okay, we need to take a q for BFS. Okay, and we need to push the initial position to the q position and move. Q dot push position is 1 and move is 0. Okay, so this is position and move. Okay. Next we need to take a visited array also. So let visited equal to visited set, visited set. Okay, so visited set visited, and we'll add this number one position is visited. Okay, visited dot add position 1. Okay, typical BFS while queue is not empty, okay, queue is not empty, then we need to get the position and move. Okay, position move from, if we are sorry, it will be NQ, here it will be q dot dq. So q dot dq will get the position and move. Okay, now we need to roll the die. What will be the options? So it will be 6 options we'll have, 1 to 6. So for let try equal to 1, I less than equal to 6, I plus plus. Okay, so what will be the next position? So next position would be current position plus I. Okay, so let's declare the method over here. So where get row column from position, so we will pass the board and position number. Okay, and this will give us the row column number. Okay, we'll write that later. Okay, let's try to get the row column number from this position number, row column number from this position, which is first call this method. Okay, and pass the board and the next position. Okay, now we got the row call, right? So now we need to find out whether we can jump through the ladder or the snake or go back to the snake. So if board row column not equal to -1, then next position would be board row call. Okay, so this we got. Okay, so if we are at position 2, then we can jump to position 15. So this will give us the result. Now we need to get whether it is visited. So this next position we need to get whether it's visited or not. Now if it is now the next position, let's say we are at 35. Okay, now the next position is we got 36, right? So we need to return the result as well. So if the next position is equal to n cross n, then return if the next position equal to n cross n, then return move plus 1. Okay, so with the second move, so currently we are move whatever the move we have, then we need to increment the move over here. Okay, and next is if next position is not visited, so visited does not has the next position, so you have not visited the next position, then we need to visit it and mark it visited. So if it is not there in the visited position, then we need to add the visited position, visited or next position. Okay, and we need to push into the queue as well. so we need to enq into the queue, q dot enq position, next position, and move, we need to increment move +1. Okay, so this is done. We need to mark the visitor as well. So visitor we have add, okay, so mark, we already done it, visitor dot add next position. So we already visited the next position. We need to have pushed the, so here by mistake I added the extra dot over here. Okay, I think we are good over here. Okay, if we cannot visit, if we cannot get, so you can basically return -1. Okay, if you cannot go to the last cell. Okay, now over here how to get the row column from the position. Okay, so what to be the n over here, so let's take n is the board dot length. Okay, and row would be n minus, position -1 divided by position -1 divided by n. Okay, and here we need to floor it, and in Java it will be integer division if you take integer, and column would be position -1 modulo n. So position -1 modulo n, this will be the column number. Okay, but we need to get the column number for the odd rows. Okay, so if row modulo 2, if it is not 0, then it's odd, then we need to calculate n -1 minus column. So this will be the column from the left to right. Okay, similarly we need to get the row from the top to bottom, so row would be n -1 minus row. Okay, and this we need to return it. Okay, let's check if there is any typo over here. Q and Q visited Q 1 to 6 position. This is position plus I. Okay, board row. Okay, this is fine, this is fine. Move +1 if visited next position in the right, NQ, and this is I guess NQ next position move +1. Let's try to run it. Okay, we're passing. All right. So time complexity for BFS in a directed graph is b plus e. So over here, what is b over here? So it is how many vertices over here? So it is n square, right? So n square vertices we have, and how many edges? So maximum we can have 6 n square edges, right? So which is 6 n square. Okay, 6 into n, 6 n square. So now what will be the effective time complexity? It will be n square only, right? Okay, and what will be the space complexity? Our space complexity, how many vertices we have? So we have n square vertices because it's n into n matrix. So to keep it is into the queue or into the visited, right, we'll need n square space. Okay, so n square. Okay.